Okay, in this video we're going to talk about segment addition postulate. This we can use when we have 3 points that are collinear to each other, A, B, and C, where B is in between A and C. If we have that situation, we can state that AB, segment AB, okay, plus segment BC will equal the distance of the entire segment, which in this case is AC. We can use this property to solve for x, or the distance between A and B, if we're given the distance between B and C and A and C. And I'm going to show you in the next example how to use that. Okay. Alright, so if we're given some information like SK equals 13x minus 15, that KY equals 2x plus 9, and one more piece of information of SY equals 36 minus x. In times, you're only given the information and then a blank diagram. Okay, I highly encourage you to fill out that diagram. So this may be all that you receive on a piece of paper. Okay, the next step that I'd like you to do is go ahead and fill out the information. So if this is SK, the distance from S to K is 13x minus 5. KY is 2x plus 9. And our last bit of information is that SY is 36 minus x. Alright, so using our segment addition postulate, what we can go ahead and do is set up an equation starting off with the two smaller segments added together to give us the length of the larger one. So we're going to start off with the distance of SK, which is 13x minus 5, is going to equal, it's going to add to 2x plus 9. Then that equals the entire distance, 36 minus x. Okay, so now we're going to go ahead and bring it down to the next step, is we're going to just solve this equation. First we're going to combine like terms, so we're going to combine the variables together, okay, and our constants next, because there is some simplifying we can do on this side before we start moving variables over and constants over. Okay, so 13 plus 2x is 15x. Okay, add the constants together, so that's negative 5 plus 9, which is plus 4. Okay, that's going to set equal to 36 minus x, because there's nothing to simplify on this side. Alright, our next step is we're going to go ahead and move our variables over to one side. My trick is look at the lower coefficients. So if this one has a negative 1 and 15 over here, I'm going to move this negative 1 because that's going to turn it into a positive coefficient. So I'm going to add, there's really an invisible 1 here. So I'm going to add 1x over here, 1x over here. Okay, if I add a 1x to this negative 1, negative 1 plus 1 just becomes 0, so that cancels out. This becomes 16x. Okay, I'm going to bring down the constant that I didn't need to simplify at that point. Next step is I'm going to move this 4 to the other side because I'm truly trying to isolate the variable here. Okay, and instead of adding, I apologize, the inverse operation is actually just subtract. So I'm subtracting 4 to both sides. So I'm going to bring, so plus 4 minus 4 is really 0. So I have 36 minus 4, which gives us 32, and 16x. Okay, now 16 times x, the inverse operation of multiplication is division. So we're going to divide both sides by 16. This becomes 1. Okay, x equals 2. Okay, now I forgot to mention what we're looking for on this problem. Okay, and we're really asked to find what is x, okay, what is the distance of SK, what is the distance of segment KY, and what is the distance of segment SY. Okay, so we just found that X is 2. Okay, now I'm going to go back to my colors as I throw the marker. Okay, SK is the expression they gave us was 13x minus 5, and we know that x is 2 now. Okay, so I'm going to go ahead and write down SK equals 13x minus 5, and we're just going to input what we already have, okay, for x. So that's going to be 13 times 2 minus 5. Okay, 13 times 2 is 26 minus 5, and then subtract that, that's 21. So we have our distance of SK. Next is KY, which is my green color. So the distance of KY is 2x plus 9. Okay, we know that x is 2, so that's 4 plus 9, which is 13. So the distance of KY is 13. And last but not least, we have to find the distance of SY. So I'm going to put that over here. SY equals 36 minus x. X is truly 2, so that's 36 minus 2, which is 34. So the distance of SY is 34. Okay, another way to check that is if I add the two smaller segments together, that's going to give me the distance of the longer segment. Okay, so 21 plus 13 is 32. So I know for a fact that this work is correct. Okay, all right. Now our next problem, okay, is if we're given a midpoint between two segments. So let's say if you were given the information, so this is involving a midpoint. Okay, let's say if you were given the information that Q is a midpoint of segment PR. Now you were not given any kind of diagram or anything. I'm sorry, you were on this one. Okay, so the segment we know is going to start off with P and then end in R. Okay, but when they say anything about a midpoint, that midpoint is right in the middle. So we know Q is in the middle of PR. Okay, now on this one it did come with a diagram. And it was already filled in as far as 7x minus 16 and 4x plus 2. And we're asked to find the value of x, the distance of PQ, and the distance of segment QR, the distance of segment PR. Okay, so let's go ahead and take a look at this. When you see midpoint, understand that Q is in the middle, which would represent this segment equals this segment. Okay, or in geometry we would use the word congruent. So when these two sides are congruent to each other, okay, we can use algebra to go ahead and set these equations equal to each other on either side. Okay, so I'm going to go ahead and write this down in green, so I know that 7x minus 16, okay, is going to be set equal to 4x plus 2. Okay, so both those sides are congruent to each other. Next step in solving for algebra is to go ahead and see if there's anything to simplify on both sides, which in this case there's not. So we're going to go ahead and start moving our variables over to the other side. Look for the lower coefficient, which in this case is 7, so we're going to go ahead and subtract, I'm sorry, in this case is 4, so we're going to go ahead and subtract this 4x from 7. Okay, 4 minus 4 becomes 0, so that cancels out. And then we're going to go ahead and bring this down. So then 7 minus 4 is 3x minus 16 equals 2. Now we have a constant on this side we need to move over because we're looking to isolate that variable. So we're going to add 16 to both sides. Okay. Negative 16 plus 16 is 0. And we're left with 2 plus 16, which is 18. Okay, bring down whatever is simplified on this side, which is 3x. Okay, isolate the variable by dividing both sides by 3 because this is being multiplied. This becomes 1. 18 divided by 3 is 6. So we know x equals 6. Okay, so x equals 6. Now the next thing that I'm going to look for is PQ. So PQ, I'm going to go ahead and do that in purple. I know the expression for PQ is 7x minus 16. I know that x is 6, so that's what I'm going to input that value here. Okay, 7 times 6 is 42 minus 16, okay, which in this case is 26. So the distance of PQ equals 26. Next step is go ahead and solve for the value of QR, which I'm going to do in red. So QR is 4x minus or plus 2. I know that x is 6, so that's 4 times 6 plus 2. Order of operations, I'm multiplying before I add, so that's 4 times 6, which is 24, plus 2. Add that together, that's 26. So the value of, or the distance between QR is 26. Which does make sense because if we know that this is 26, we know that it's congruent. So it's also 26, okay, and because when we're looking for the entire distance of PR, we're going to add these together or multiply by 2, okay, which is going to give us a value of, let me do this in, yeah, green will be okay. So R in this case is 52, okay. Another way to do that is you can add these together and input X, but that's a lot of work. Okay, so if you have any questions, you please email me, come see me, okay, or just leave comments below. Okay, thank you.